Good day, my name is Uncle Taki. I'm going to show you factorization in algebra because this is a very important part of maths. So I'm going to show you the building blocks. So the basic building blocks. We're going to start with an example. The example is x squared plus 7x plus 12. I will show you that the solution is x plus 4, x plus 3. So you're going to ask me, how did I get to that solution? We will go to the actual theory of quadratic equations, or trinomials as they're also known. In this case we have two pluses and the general solution is x squared plus, open bracket, a plus b, x plus a times b. So what we have to find are the factors to the actual equation. So the way we do that, starting with the first equation, number 1, we get the factors of the x squared is 1 times 1. 12 can be broken up into 12 times 1 and 6 times 2 and 4 times 3. From the general equation, we need to add the factors. So we need the two factors that make 7. So a plus b must equal 7. So if you look here at the multiples, we've got 4 and 3. So 4 and 3 will be a and b, and 4 times 3 is also 12. In fact, all these are 12. 12 times 1, 6 times 2, and 4 times 3. So that's how we came to the solution. So a will be equal to 4 and b will be equal to 3. So x squared plus 7x plus 12 is then factorized into x plus 4, x plus 3. And if we multiply this out, x times x is x squared. X times 3 is plus 3x. X times 4 is plus 4x. And 4 times 3 is 12. And therefore we have x squared plus 7x plus 12, which is a cross-check, and therefore a correct result of solving this particular trinomial. We're back again onto the second example, and this time it is x squared minus 7x plus 12. There's a slight difference. The first sign is negative. I'm going to spend a little bit of time explaining how to factorize when we have a minus and a plus. This plus sign tells you that the two signs in the factorization is going to be the same, and the first sign will tell you that it's going to be negative. So we need to factorize this with two negatives. So here our factorization will be x minus 4, x minus 3. Again, how did we get the 4 and the 3? We have our big X to have our factors of 1 times 1 for the x squared, and the 12 again becomes 12 and 1, 6 and 2, 4, and 3. Again, we are looking for a minus 7x. So we need to add two minuses. And as we've got here, minus 4 and minus 3. So our general solution to this factorization is x squared minus a plus b times x plus a times b. So if we look at this, these two factors in the binomials and multiply them out, we're going to have x minus 4 times x minus 3. X times x is x squared. X times minus 3 is minus 3x, minus 4x, and minus times a minus is a plus, and 4 times 3 is 12. And if we collect like terms, we will get x squared minus 7x plus 12, which serves as the cross-check to the original equation, which is correct. Another Funda Tanda Maths moment. I showed you the 5 times pattern. Now let us look at the 5 times multiplication, to actually multiply by 5. So if we take the number 136 times 5, is there an easier way to do that multiplication? If we remember that 5 is also equal to 10 divided by 2, what we do to this sum is we take 136 and multiply by 10 and divide by 2. And that will be 1360, and then we just have to halve the 1360, which is 2 into 13 is 6, leaving us 1. 2 into 16 is 8, and 2 into 0 is nothing. So here it is. It is 680. Definitely quicker than multiplying each number out by 5. Now we are going to look at the third example, which is x squared plus 1x minus 12. This problem becomes far more challenging, so I will need to put my thinking cap on. Right. Now we're going to study the signs. So if we look at the general solution, we're going to have x squared plus a plus b x minus a times b, where a has to be greater than b. And the solutions here are going to be x plus a, a plus x plus a, and x minus b. Now we go and do our cross check, which is 1 times 1 to find the factors, as you've seen them before, 12, 1, 6, 2, and 4, 3. So we need a positive 4 and a negative 3. Therefore, A will be 4 and B will be 3. So our solution here is going to be x plus 4 and x minus 3. To check that we get back to equation number 3, we multiply them out. So we'll have x plus 4 times x minus 3. So x times x is x squared. X times 4 is plus 4x. Minus 3 times x is minus 3x. And minus times a plus is a minus, and that gives us 12. Therefore, we've got x squared plus x, the difference between 4x and 3x, minus 12. And this is our cross-check showing us that the answer is correct. Let us look at the reverse of multiplying by 5, or the inverse, which is the division by 5. So let us take our answer of 680. 680. So division by 5 is the same as 680 divided by 10 times 2. So if we come across here, we will have 680 times 2 divided by 10. The tens, the noughts cancel, and then 2 8s are 16, carry 1, 2 6s are 12, and 1 is 3. 136, which was the original problem. So you can see that you can use the multiplication smart or the division smart, again multiplying. Now we're looking at the fourth example, which is x squared minus x minus 12. So again, we're going to end up with our two binomials. This time we're going to have an x minus and we're going to have an x plus. When you have a minus in the second place of the trinomial, you're going to end up with a minus and a plus. So if we go again and do our factorization, by now we know it's 1 times 1 for the coefficient of x squared. And then for the constant, it's 12, 1, and it's also 6, 2, and it's 4, 3. This time, when we sum our two factors for the coefficient of x, we require a minus 1. So this is going to have a change in the signs. So here we're going to have 4, and there we're going to have 3. So let us do a cross-check. So we cross-check this. So you have x minus 4 times x plus 3. So x times x is x squared. X times minus 4 is minus 4x. Plus 3 times x is plus 3x. And plus 3 times minus is minus 12. We add vertically down. We have x squared minus 4 plus 3 will give us minus x and minus 12. As you can see, the cross-check balances off with the original trinomial. So our factorization is correct. I will now show you the generalization of this type of trinomial. So here it's x squared plus minus a plus b times x plus a times b. And the solution is x minus a and x plus b. In this case, we have minus a plus b, which is less than 0. So if you look at our example, we had a 4, a minus 4, and a plus 3. So minus 1 is less than 0. Therefore, that is our generalization. I'm going to take a minute to go through the different signs that I'm going to summarize the signs for you. So if we look at the first one, the signs are x minus, plus and x plus. The signs here are going to be x minus and x minus. The signs here are going to be x plus and x minus, and the signs here are going to be x minus and x plus.